Okay, let's start our session. So I hope my slides are visible to you. Okay. Is it visible, Udbhav?
Yes, sir.
Okay. So good evening, good evening, all of you. I'm Karthik Jadhav, research scholar in the Department of WRDM IT Roorkee. So I welcome you all on today's course of Soil Science and Technology. So course basically conducted by Professor Chakravarti from IT Kharagpur, Department of AGFP. So before we begin, let me introduce myself briefly. So as I already told, I'm third year PhD scholar in the Department of WRDM IT Roorkee, and I completed my masters in Land and Water Resource Engineering from IIT Kharagpur, and my bachelor's in Agricultural Engineering from College of Agriculture Engineering and Technology, Godhra, Anand Agri University. So I also worked as a junior research fellow in the project called Design of Climate Resilient MR Strategy for Hindon River Basin. And currently, I am a Prime Minister Research Fellow at IIT Roorkee. So currently, I am working on the same project, but the version is extended. So I am working on developing climate resilient agriculture-based managed aquifer recharge strategy to supply safe water in the contaminated and overexploited regions. So I am the teaching assistant for this course, and in this session we'll continue with the some basic overview of the particular week, and then we'll quickly revise that whatever topic we have covered in the week lectures. Then we'll also solve question and answers related to that week content. So this is my contact information, email address, right? So if you have any queries, you can directly email me on this email ID. Okay. So before we begin, let's quickly introduce yourself. Okay, participants. So we'll know about each other. So let's begin with Udbhav. Hello.
Hi, hi, hello.
Yeah, please introduce yourself by.
Hi, sir. My name is Subhav Dedi. I have completed my BSc Agriculture from Ram Manohar Lohia Award University.
Which
Currently, I am
sorry, which university?
Ram Manohar Lohia Award University, Ayodhya,
Okay.
and currently I am preparing for IFS, UPC IFS.
Okay,
Uh, I have passed BSc Agriculture on. I graduated BSc Agriculture on 2020 in
okay,
October. Okay,
okay,
that's it, sir. I'm from Gorakhpur, Uttar Pradesh.
okay.
Okay.
Currently, you are in Gorakhpur only, or you are staying somewhere else?
No, no, currently I'm in Gorakhpur only.
Okay. And what's your hobby? Hobbies?
So playing cricket and all.
Okay. And why did you choose this course? Any specific interest? What you want to learn from this course? What are your expectation? What are your expectation at the end of this course? Hello, hello. Am I audible? Okay. I think we have some network issue. Payal, begin our session. Okay, right. So this is the course outline that we have already gone through in the first week content. So total, we have 12 weeks, and each week contain 5 lectures, and these are the description of that lectures topic. So today is the date 24th January 2025. So in last week we have gone through the basic overview of soil, its ecosystem services, how soil is formed, evolves. So fundamental process that cause the soil formation. So basically, we know that is a soil weathering. Then we have also gone through various soil properties. In brief, we'll also go on through them in upcoming lectures. Okay, so our lecture timings for this problem solving session will be on each Friday, 6 to 8 p.m. Okay, so before we begin, let's understand what are the learning outcomes we are expecting at the end of this course. Okay, so according to Bloom's taxonomy of educational objective defined by group of educational experts led by Benjamin Bloom. So that says that any learning process starts from remembering. So remember, whenever we are child, so what we are doing, we are just remembering something like numbers, ABCD, right? Then what we are doing, what we did, that remember the ABCD or numbers or sum, subtraction, multiplication, all this we have converted into some understanding, like right in real life understanding. Then we move towards applying that knowledge further, right, in real world. Then what we are doing, we are analyzing our knowledge, and that by analyzing, finally we are evaluating, right, by giving various exams. What is our knowledge, like creating some project, and then finally whatever knowledge we have gained throughout our education system, like from 10 12 bachelors, we are creating some new knowledge, right? So in similarly for this course, what is the our understanding, and what we are expecting, we will try to understand, and will explain some fundamental concept of soil science and technology. Along with that, we'll also analyze and utilize how we can utilize and analyze available soil data for designing soil and water management strategy. Okay. We'll also understand briefly why it is important to conserve our soil and water. Okay, in upcoming slides. Then we'll understand the problems through this available data, right? Like what are the major problems and what are its potential solutions. Then that knowledge will try to apply, uh, try to uh, understand that problem and will link it with actual real world problems. Just a minute. Hi Ashish.
Hello, sir.
How are you?
Fine, fine, sir. How you are?
Yeah, I'm fine. I'm fine. So let's quickly introduce yourself and uh, then we'll continue with our lecture.
Okay, sir.
Yeah.
My name is Ashish Koradia. I am currently as a research scholar
Okay.
in Department of Water Resource Development and Management, IIT Roorkee,
Okay. Mighty Ruki.
and I am working on water security assessment.
Okay. So what's your hobbies and from where you are and why
My
did you choose
hobbies,
this school?
yeah, my hobby is to play the table tennis and explore the new area, unseen areas in the India,
Okay.
and I choose this subject because it is very related to the my research area. So
Okay.
to gain the good fundamental understanding of the basic things in the science in the process of the soil and the water. That's why I choose this course.
Okay. Thank you for joining this course. Let's continue our
Okay,
session.
thank you, sir.
Okay. Yeah. So what we are discussing is Bloom's taxonomy of educational objectives, right? So the final step is to create some new knowledge, okay, and develop a real life solution. So at the end of this course, you have the some fundamental knowledge. You need to remember that. Then you need to understand that properly. That will also discuss. Also, whatever we are remembering and understanding, that we will apply to some real concepts, real problems that we found in soil. Then we'll also gain our understanding on analysis of that problem, how to evaluate that particular problem, and after all this process, whatever understanding we will gain, we will able to create some new knowledge, okay, or now new problem solutions. So before we begin, let me quickly introduce the fundamental of soil and water and its availability. So as we know that we are living on the world of ocean, right? Because 97.5% of water available on Earth is salty water, while only 3%, or we can say 2.5% is a fresh water. In that also, we have three part, right? And out of total available fresh water, we have only 3% available in lakes and river storage, right? That is in kilometer cube is this, and around 31% available in groundwater. So basically, we are using this water for our daily life use, either it is agriculture, domestic, or hydropower generation. So you can see that it's a very tiny amount of water that is available for our daily life use. And if you know that we have total currently 7 billion population on the world, and the world production of cereals, if you see from this graph, that is production of cereals around in 1970s, it is 300 kg per capita, and in 1984 it drastically rise due to green revolution. Then currently we are at around 315 or 10 kg per capita, right? What is the problem here? We have more than 2 billion people with us by 2050. It means we have total 9 billion population on the earth, right? But if you see the volume of water available for our daily life use is constant, right? And similarly, land on earth surface area is also constant. So due to that, what will happen? Due to that, whenever the population will increase, the per capita availability of these natural resources will decline, right? Due to that, what will happen? The problem of food scarcity and water scarcity, also land resource scarcity. Apart from this basic fundamental problem, you can see the per capita land availability degradation for developed countries, and world. So this graph highlights this, and you can see this line for three different regions or three different categories. That is drastically declined, right? And similarly, for per capita water availability, that is also declined. So it clearly indicates that we need to manage our soil and water resources very effectively, right, to feed our future generations. Apart from that, if you see this world soil condition map, so that shows the stable soil, areas of some concerns like soil erosion, right? Areas of serious concerns means in these areas, soil erosion is higher than soil formations, right? And this white area shows the non-vegetated land. So if you see here India, right? So majority of the southern India, southern or western Indian part are have areas with a serious concern of soil erosion, right? Due to the conditions like weather, climatic conditions present there. That is basically the kind of soil present, or we can say the temperature or rainfall pattern. Okay, so that's also like we have the population of around 125 or 130 crores, right? And that will also predicted to increase by near future. So within this limited land availability and water resource availability, we need to manage our resources effectively. So here for Indian scenario, we have the total renewable water resources of around 1123 billion cubic meter, and we are extracting 720 billion cubic meter water. Okay, and out of which 90% of water we are using for agriculture. Just a second. Hi Gaurav. Hello. Okay, let's continue our session. Okay, so what we are discussing, yeah. So most of our water we are using in agricultural sector, right?
Yes, sir.
And okay, Uh, sorry, Gaurav.
Yes, sir.
Okay, please introduce yourself. So,
Good evening, one and all present over here. My name is Gaurav Das. I'm from state Odisha and
okay,
currently pursuing my BSc Agriculture degree
okay,
of third year. So I have opted this course as an interested student towards soil science.
okay,
So
okay,
uh, this must thank you.
okay, okay. So, what you are expecting at the end of this course? Like, what are your learning expectation or any particular thing you are interested in?
Yes, sir. Of course, sir. My particular aim is to gain a particular knowledge about this
Okay,
soil
soil
science.
science. Okay, right, right.
Yes, yes,
Okay,
sir. Actually, I am going through a mental storm about what could be our future in soil factor or any uh,
okay.
plant growth relating to the soil factor.
Okay, okay, perfect. So you join at right time. So we are discussing that only fundamental problems about soil and water. Okay. So let's continue. What we have shown that our natural resources like soil and water are constant on Earth's surface, right? In India, we have
Yes, sir.
total 4% global water resources. Okay, while soil is of about 2.3% of world land, world soil. While we have 17% of the world population in India, right? And this number is still increasing. Okay, and at a global scale, we have data that says that we have more than 2 billion people with us by 2050. Okay, it means these numbers, the per capita availability of this natural resources, water and soil, also we can say the food, right? Because whatever we are producing from this is food, okay, and this is also the some critical challenges that we can say. So apart from that, what problem we have? We have the problem of water pollution, soil pollution, groundwater level depletion, aquifer contamination, interstate water dispute. We can say. Then we are in India. We are growing water intensive crops like sugarcane, rice, and also exporting that crop to other countries of the world. Due to that, what will happen? Our water are driving right from one region to other region. So that will also cause the water scarcity issues in upcoming future. And if we can talk about per capita availability of the water, that is around uh, 5177 meter cube per capita in 1951, and in it become 1545 meter cube in 2015 for India. Okay, so you can see these critical challenges, and due to that, it is very important to understand the soil conditions, understanding some fundamental of soils, and what are the technologies available to understand that, and what are the properties, how soil forms. So once we have this all understanding, then we'll able to understand the where we can contribute in the existing problem. Okay, that's why we are learning this course. So before we start solving our question answer session, let's quickly revise the week one content. So in week one, we have went through some basic properties of soil. What is the soil? Then its branches, its functions, and the composition. So what is the soil? Soil is the unconcentrated cover on the earth that is made up of four part. Okay, that is mineral, organic component, water, and air. And then we saw the various branches of soil science, like soil pedology, soil chemistry, soil physics, soil biology and biochemistry, soil fertility, right, etc. A pedology is deals with the what is the nature of soil, what is its origins, right, how it can form. All this deals in the pedology. Then we have the soil chemistry. So soil chemistry means chemical properties of soils and how it will help us to understand the soil pollution. Then we can say soil physics, so means physical properties of soils and what is its role, what is its roles in the water movement, water pollution, that we can understand by learning soil physics. Similarly, lots of branches there. We can relate it uh, with the real life problem. Then the fundamental functions we have went through of the soil, that is the it acts as a medium, right? Medium for plant growth. As we discussed in previous slides, the basic needs to for living things is for human is food, right? And food where we are growing on soil. And apart from soil, what we required? Water. But these resources are declining nowadays, declining per capita also, and also degrading by lots of issues by like such as anthropogenic activity, climate change, right? Second function is the habitat for a soil organism, so making up more than half of life on the planet, right? Then it also acts as a biochemical or nutrient reactor, means soil have the properties to absorb, release, and transform the inorganic and biochemical compounds such as essential plant nutrients, pesticides, minerals, heavy metals, and numerous other compounds, emerging compounds, right? Then it's also acts as a hydraulic buffer. Hydraulic buffer means whatever soil we have, soils have different properties, soil physical properties, right? Based on it have the water holding capacity, nutrient holding capacity, then its drainage capacity, and this all fundamental understanding will help us to decide the when we need to irrigate, how much we need to irrigate, what amount of fertilizer we need to apply, right? And after that, we went through the soil formations. As we discussed, the soil is form of four major components. So air and water. So air is in particular soil, 25% of the air is present. Similarly, 25% of water. Then if we talk about minerals, it have 45% and organic matter of 5%. So it total all of these compounds that made up the soil. And soil mineral matter fractions, if we talk about, so basically we can classify soil as a clay, silt, sand, and gravel. So clay soil we can classify as whenever the particle size of particular soil is less than 0.002 mm, right? That is known as clay soil. While for silt, it is between 0.002 to 0.05 mm. Sand is a relatively larger particle than silt and clay, and its size is in between 0.05 mm to 2 mm, while gravel is greater than 2 mm and it is up to 75 mm. So this is the again same classification here, and that we already discussed in the week 1 content. Then this is the in details of the soil organic composition. right, in uh, soil formation. Then we shown the colloidal properties. So generally, we can say that the clay size particles, which are smallest, we show the size of clay particle, right? It is less than 0.02 mm. So whatever particle present in the soil, that is if that is less than 0.02 mm, that is known as clay, and these clay particles contain the colloidal properties, right? And what is that? That adhere together to form a sticky mass when wet and hard clods when dry, right? Similarly, the smaller particle less than 0.01 mm of clay and similar size organic particle have colloidal properties as we discussed. So these colloidal properties, so colloidal particles, that is have a very small size, right? What will happen due to that? Whatever chemical we are applying on soil during agriculture, that gets adsorbed on this. I think someone tried to join, but don't know. Sabrin. Okay. Hi, Sabrin.
Hi, sir.
Okay.
Yes.
So, how are you?
Yeah, I'm doing well, sir. How are you, sir?
Yeah, I'm fine. I'm fine. So let's quickly introduce yourself. So we already started our session, but
Uh,
since this is first week of this session, so we'll get.
okay, sir. I'm Sabreen Sadak from Institute of Remote Sensing, College of Engineering, Gindi. I am currently pursuing my full-time PhD. Uh,
Okay.
yeah, so I have enrolled for this course as part of my learning for PhD coursework, sir.
Okay. Okay. Perfect. Okay. Thank you for joining. Let's
Yeah, yes,
continue our
thank you.
session. Right. So we discuss about the colloidal properties of soil. Then soil water. Again, we discuss about water, why it is important, why soil is important, and what is soil water. Whatever water present in the soil particles, and that is available to any crop that we are growing, right? Because if we are growing our crops only on soil, that is not able to grow, right? The fundamental requirement of any crop to grow is water and some chemicals based on the soil chemical properties. So soil water is the water present in the soil, right? So there are three types of water. The that is a free water, then the water present in between the field capacity and permanent wilting point. That one water we can call that is above wilting point, that is not easily extracted by plant, and the water that is available that is at ultimate wilting point. It means the water is present in soil particles, right? And plant requires too much of pressure to extract that water. So whatever water present in between field capacity and permanent wilting point, that plant can get easily. Also, apart from that, the water that is available freely, that also can get utilized. But that water drains quickly from the plant. Hi, Shambhavi. So I hope you got the concept of soil water and why it is important, properties, and it's obviously it is differs from the glass of water. We know that the water present in the soil is not directly available as we discussed, right? It forms in a various it holds by soil at various pressures, and plants needs to apply that pressure to extract that water. Then soil solution. So the soil solution generally we are using for determining soil chemical properties. Then soil acidity, soil alkalinity, that concept we went through. So basically we know that when soil pH is above 8, above 7, sorry, that is soil known as the alkaline soil. And if soil pH is less than 7, then that is a acidic soil. Then soil aeration. So we know the soil composed of air, water, minerals, and organic matter. So soil aeration is also the fundamental requirement. If proper aeration is not there, that will cause the plants to die because all plants are not water sensitive, right? Like rice and sugarcane, that can sustain the excess water, but the most of plants are not able to do that. Right, so it is important to understand the soil aeration properties. So basically, it provides the ventilation. Okay, and soil air is composed of three major gases. That is nitrogen, oxygen, and carbon dioxide. And major soil is composed of the nitrogen gas. That is about 80%. Then we have the oxygen of 20%, and CO2 it is of 0.25%. Then in continue with that, we have shown the some fundamental properties called weathering. So that can define as the disintegration and decomposition of the rocks at the earth's surface by the action of physical, chemical, and biological activities. And we have also shown the rock cycle, right, that we'll also discuss in upcoming slides in detail. So basically there are four types of rocks. That is a magma that basically caused the formation of the igneous rock. Then we have the sedimentary form. So due to the weathering of the igneous rock, there is a formation of sedimentary rock, and after sedimentary from sedimentary rock there is a formation of metamorphic rock, and again this metamorphic rocks form the molten magma below the earth surface by cementation and overcomposition on a particular metamorphic rocks. And then we also discussed physical and uh, basic types of weathering process, that is either physical weathering, chemical weathering. Physical weathering, we know that it's also known as the mechanical weathering. So in that, basically what is happening, the particular rock, assume that this is the igneous rock, right? Hard rock, like basalt. So what will happen due to the physical and chemical process? So physical means it is by climatic properties, like uh, rain, then wind. Due to that, what will happen? There is a breakdown of this hard rock into the small particles. So again, by favorable climatic conditions, these particles went to move from one place to another place. And these particles again break down by favorable climatic condition into very small particles, right? And this very small particles that we saw of different size, we can say them it is as a soil. Okay, and this diagram we have also discussed and show that how soil gets formed. So basically, we have the rock. Okay, disintegration of rocks by rain here it shows. So due to the rain, we have the force, right? Rains have kinetic energy. Due to that, what will happen? That energy leads to breakdown of this rock over the time. It is not the one-time process. So over the time, based on the intensity, frequency, and duration of rainfall events, and also the temperature before rainfall event, all these factors will lead to the disintegration of rocks. Then the soil forms a larger particles, as you can see here, similarly, right? So in simple organisms, what is happen? On the top, we have some organic matter and some larger particle. So at this stage of the soil formation, we have the two forms in the soil, that is of organic matter, and we have we can see here the development of sea horizon. Then on next stage, over the time, this particles again gets break down by various favorable condition, climatic favorable conditions, and development of other soil horizons like A, B, C, right, D and E. Then we have also discussed the chemical weathering processes, and the chemical weathering processes like hydration, right? So that is due to the adsorption of water molecules to the crystalline structure that cause the expansion and weakness of the particular structure. Then hydrolysis again, that is in presence of H2O water, as you can see here, that forms different solids and colloids. Then dissolution, that is again the process by which rocks dissolved in the water. Okay. Then we have the acid base reactions, carbonation. So you can see the whenever there is a presence of carbonic acid, that is H2CO3, the chemical weathering is happen of particular rock and its form the different composition. Then we have the oxidation and reduction processes. So whenever so it is not like that this all process is happening individually. All these processes have interconnections. So whenever we have the process of hydration, hydrolysis, that is also parallelly happening, oxidation reduction process. Then complexation process, that's also like combined process. Okay. Then we have also shown the biological weathering. On week 4, we have we went through some soil formations, basic soil formation, right? So soil formation is brought about 4 basic pathogenic processes, that is addition of something to soil, then losses from soil, transformations, and translocation. So what is addition? So addition of water to the soil. Okay. So whenever rainfall will happen, or whenever we are providing irrigation, what will happen? The that water we are giving, that will percolate or infiltrate to the soil. Then dust adds minerals. So whatever wind is coming, that wind coming from one place to another place, that brings dust, and that dust contains various minerals. Okay. Then animals, humans, we can say, what we are doing, they are adding organic matter, nutrients, okay, by animal etc. Then we are adding fertilizer to grow crops. Okay. Similarly, what are the losses? So losses of this added water. Okay. Suppose whatever water we are adding, that are going downward by infiltration process. And based on the soil properties, the soil will store the water, and some water will also move downward below the root zone, and root zone we are generally considering as 1 meter. So whatever water will go below a root zone, that is cause the percolation process, that is known as percolation process. So the losses of this water by percolation process, and this water will go down towards the groundwater. Okay, groundwater. You know groundwater, I hope. So we have the aquifers present below our soil surface that contain water. Okay, and we are also extracting this water for our daily life use. So losses by evaporation. Then erosion carries soil particles. So what is erosion? So erosion is defined as the movement. So basically, detachment, transportation, and deposition of soil from one place to another place. So suppose we have soil here. Whatever rainfall will happen here, what will happen due to that? We discussed that rainfall have some kinetic energy depending on its duration, frequency, and intensity. So based on this kinetic energy, the soil particles gets detached. Okay, so that detached particle, if you have observed the rainfall, sometimes the after few rainfalls, like whenever monsoon begins on June, what is happening? At that time, we don't have the event like flood. Okay, because the soil is in a dry condition, right? Because of previous summer. So over the time, what will happen if rainfall falls continue for 3 4 days in June? The soils get saturated. Saturated by what? Water. Because whatever water is falling through rainfall, that gets infiltrate into the soil, and the soils have particular water holding capacity, right? And that water holding capacity, what will happen due to that? After some times, that water holding capacity of particular soil gets fulfilled. Okay, so after that, whatever rainfall will happen on this soil, where the water will go, it will move as a runoff. Okay, so whatever soil particles get disintegrated, okay, during few initial events. So whenever runoff gets started in this soil after its water holding capacity gets reached, this soil particles also starting to move from one place to another place. Okay, and this movement will continue till the runoff will continue, and after some times of some days, few days, what will happen? This particles from this place to this place gets deposited. Okay, so this complete process is known as soil erosion. So soil erosion is defined as detachment, transportation, right? Detachment by some kinetic energy forces, either it is a rainfall or wind. Then transportation of this particle and detachment at some another place, from one place to another place. That complete process known as the soil erosion. So this is the losses. Okay, then organic matter decompositions, right? Again, this is due to the various activities, either it is by some chemical processes or physical processes. Then nutrients and mineral leaching down. So as we discussed in this diagram, what is happening when the, suppose again this is fresh soil, let's assume this is a agriculture soil. Okay, so in this soil, what we are doing, we are growing some crops. Okay, so in these crops, what we are applying, we are applying irrigation. Also, we are depending on the rainfall. Apart from this, basic requirement is to apply essential plant nutrients, and that we are applying by fertilizers, pesticides, and other agrochemicals. So whatever chemicals we are applying to the plant, so if you aware about that, in India, so traditionally, most of farmers are applying fertilizers and agrochemicals blindly, right? Nowadays people are gets aware and they are applying it more efficiently. Still there are practices like over fertigations, right? Just a second. Okay, right. So there is a problem of over fertigation. uh, okay, no problem. So again, let's draw this. So over fertigation, due to that, what will happen? Whatever fertilizer we are applying on our soil, and how, what do you think? How the soil is taking these nutrients? Anyone? Gaurav? Let's discuss so we can clarify our doubts if you have any. I think two-way discussion is essential. Anyone? Deepak, Vinod, Uddhav? Hello, Payal. I hope I am audible to you. Hello, hello. Are you there, guys? Okay. I hope you are there. Okay. Let's continue our session. So, right, whatever fertilizer we are applying, will that also require water to get dissolution in water, right? Because plants cannot extract the solid form of chemicals, plant essential nutrients. Along with these chemicals, we also need to apply water. So these chemicals get dissolved in water, and along with water, plants also get the essential nutrients. But what will happen if we are applying excess nutrients and excess agrochemicals? Whatever chemicals we are applying, if it is excess, that plant cannot take the excess chemicals. It will. It is like our capacity. We cannot take too much food beyond our capacity, right? So due to that, whatever excess chemicals is available here, what will happen to that? That will leach down. Okay, leach down through soil. So leach down into the aquifer, also move along with the runoff. So basically, it will end up at the end of river, oceans, and it is polluting our water resources, and also slowly it moves down towards the freshwater aquifer and contaminate our groundwater resources. Okay, so that is the one major loss so that we discussed. Then we have the transformation process. So in that transformation, the process of modification and add or destruction of existing soil components. So that is as a result of weathering, synthesis of secondary minerals. Then weathering alters the size of minerals. So we show that the breakdown of the bigger rock to smaller particles, then ultimately the formation of the soil. And the final process is formation is translocations, means movement from one location to other location, right? That is by water that we show along with the runoff. The soil also move, nutrients also move. Okay, so you also heard the term called sedimentation that will generally happen in our dams, reservoirs, rivers during flood events. Then we have also evaporation that translocate the salts to the surface, right? So what will happen by if evaporation is high in particular area? So if you observe in some arid regions like Rajasthan, what is happening? The due to higher evaporation, whatever salt present in the soils, and that soils get developed either it is naturally or by applying over fertigation over agrochemicals to our soils, that this salts present in the top surfaces of the soil that will come up along with the evaporation, right? So this soil present beneath the soil surface, that also will come at top surfaces, right? And that known as the translocations of salt. Then we also have some organisms that carry minerals or materials from one place to another places, and the fundamental functions or properties that affects the soil formation, that is climate, organisms, relief, planet, parent materials, sorry, and time. Okay, so that we have already discussed, and all this we can relate with the this fundamental process that we saw of the soil erosion, right? That is detachment, transportation, and deposition. Okay, so deposition from one place to another place. Then in week 5, sorry, lecture 5, we shown the types of parent material. Okay, we are not discussing in this in detail, and also shown the soil horizons in details, and soil horizons consist of various groups and also subdivision within this soil horizons. or we can say master horizons. Here you can see the soil profile, soil horizons also. So we can also call this as a soil horizon. So it consists of various horizons like O, A, E, B, C, and R, and all these horizons contains the different minerals as well as organic matter, and it develops over the time. So before we go ahead and solve the question and answer, uh, if anyone have any query, please ask. Okay. So if you have any question or queries, you can also write in the chat box if you are not having proper connection, internet connection. Okay, I hope you are following me and getting whatever I'm delivering. So let's take here a small break, and we'll after 4 5 minute break we'll rejoin and continue our session and solve the question and answer session. Okay, let's resume our session. So, first question is, which of the following particles is the biggest? So, option given is sand, silt, clay, and or are of equal size. So, we discussed already the soil. We can classify it majorly as a sand particle, silt particle, and clay particle. And sand have particle size of 2 to 0.05 mm, that is the biggest, and biggest than sand we have also gravel. Okay, but here we have also only option of the sand, silt, and clay. And silt have a particle size of 0.05 to 0.002 mm, and whatever below this 0.002 mm, that is known as the clay particle. So here you can also see its size. So this is not actual size, but we can compare. Sand have the biggest size. After that, we have the silt and then clay. And based on this, we have also different water infiltration and water holding capacity of different particles. Right. So, what is the correct answer here? Biggest particle. The correct answer is sand. Right. So, sand, silt, and clay. Next question, which rock is formed from volcanic deposits? And the option given is igneous, sedimentary, metamorphic, and all of the above. So we know that this diagram represents the rock cycle and is a continuous process that describes how rocks are transformed from one type to another over geological time, and it demonstrates the interaction between Earth's internal and surface processes. So here you can see from this diagram that the molten magma present beneath the Earth's surface that gets exposed, right, due to the excessive heat and pressure, and that forms the igneous rocks, and basically this magma gets out during volcanoes. And the common example of igneous rocks is basalt rock and granite. Okay, so whenever this magma gets cooled down after volcano, it forms the igneous rock, and when this igneous rocks gets melting, it forms the magma. So it is the reverse process also. So it is cycling process. Then once the igneous rocks gets formed, and whenever there is a favorable weathering conditions, and this weathering condition cause the erosions. What are the primary factors for erosion? The water and wind. water by rainfall, over irrigation, and wind. Okay, that gets erode the soil. And what is erosion? Erosion is detachment, transportation, and deposition. That known as the erosion. And that erosion, what is happening during erosion, that we already discussed. This bigger rocks gets disintegrated into the small particle. Okay, and this is known as the sediment. And again, the sediments gets transported by erosion process. Okay, and that we are getting in the river sediment. And this sediments over the time during deposition, it forms the sedimentary rock by the process of compaction and cementation. Then these sedimentary rocks, by the heat and pressures, it forms the metamorphic rock. And metamorphic rock, melting of this metamorphic rock form the magma. Okay, and the common example of metamorphic rock is marble, slate, and for sedimentary rock it is a sandstone. So here the correct answer is the rock formed from volcanic deposits. So you can see here by volcanic deposits what is forming here, that is igneous rock. So option A is right. Next question, how will you calculate the standard deviation? So what is standard deviation? Generally, standard deviation we are using to know the spread and dispersion of data related to the population mean. Okay, means how the data gets varying along the means. Generally, we are representing mean. Any data we have, we are generally representing them as a mean plus standard deviation. Right. So standard deviation means how far any like we have the range of data, right? Suppose height of numerous students, that is 5 feet, 6 feet, 7 feet, 8 feet, 9 feet. So what is the average of this? That this is 7 mean, right? Mean height. And if we want to identify standard deviation of that, what we need to do? We need to calculate it by this formula, which the option B, right? That we are using generally. So for that we require the observation that is here. Then it means that is 7 and number of observation that is n, so 5. After that what we'll get? The standard deviation. So the standard deviation give us how our data means how our data is varying. So if our standard deviation after this, suppose we will get 2, it means we can represent it as mean plus or minus standard deviation, that is 2. Okay, the sigma value will get 2 after calculation. It means our data is varying from 7 plus 2 to 7 minus 2. So you can see here 7 plus 2, 9, right? 7 minus 2, 5, like that. And how we can use this concept in soil science or any uh, weather data or irrigation data, any data, how you can represent that? So it help us to understand the variability, also help us in the risk assessment and statistical comparison of different kind of soil. So option B is correct. Next question, which one of the following is an organic fertilizer? So ammonium chloride, ammonium sulfate, urea, or none of the above. We know that ammonium chloride is a inorganic fertilizer, right? And basically it contains the nitrogen in the form of ammonia. Then we have the ammonium sulfate. Again, it is the nitrogen fertilizer, synthetic and inorganic fertilizer with high content of nitrogen, and we are generally using it to correct the soil pH. Okay. Then urea, again, this is nitrogen based fertilizer and synthetically produced from ammonia and carbon dioxide. So none of the above is organic fertilizer, right? Because organic fertilizer is made up of compost, manure, and bone meal produced from animal and plant sources. Next question: among soil or microorganisms, which one has the biggest population? We know that bacteria have the biggest population. Then next question: soil contains. So we know that soil is made up of four major part. We have the air, okay. So so we know that soil that contains the four major, right, consist of four major part, and in that 20% is filled by air, 20% of water, 5% of organic matter, and 45% of mineral. And in organic matter also we have distribution of organisms, roots and humus. And among organic matter, the major part is composed of humus. So the right answer is all of the above. So next question, according to ICR, total number of agroclimatic zones of India are, anyone have the right answer? Okay, so what is ICR? ICR is the Indian Council of Agricultural Research. So it is located in the New Delhi. So ICR defined the total 15 agroclimatic zones. Okay. And these agroclimatic zones defined based on the similar climate, based on the type of soils, moisture design, type of agricultural practices suitable in that particular region. So these zones have the similar characteristics, and how this classification help us in. So it is help us in planning and carrying out the agricultural strategy more effectively across the different region of India, right? Because we cannot implement the same strategy throughout the India. We need to adapt the strategies, agricultural strategies. We need to grow agricultural crop based on the climate suitability, whatever soil types is there, what is the water holding capacity, all this we need to consider. So in that context, agroclimatic zones help us to decide even the soil and water conservation strategies we need to implement in particular region, that also depends on the agroclimatic zones. So correct answer is C, 15. Now the average annual rainfall of India in millimeter is which one? Anyone? Hello? Hi, Sweti. Sweti, do you have any answer? I hope you are getting my voice. So the correct answer is 1200, right? Exact amount is 1190 mm. Okay, but it is near to this 1200. So this is the correct answer. And rainfall over the India, it's get distributed. It's varying with the very high range. In northeast, we have the highest rainfall, right? That is above 400 centimeter. We can say 400, 4000 mm. And in Rajasthan, we have 200 mm, right? Similarly, from north to south, also it is varying. All this factor we need to consider, right, during our agricultural planning or any planning, right? Like even if we are made up our own house, in that also we need to consider the rainfall pattern, because this rainfall pattern directly related to the whatever water present in our groundwater resources, our surface water reservoirs, etc. Which operation is specially done for rice cultivation? So this is the common question, right? So if you have heard, this puddling is the right answer here. And what is puddling? Puddling is a operation done in the rice fields where soil is plowed and water is incorporated into the soil to create the soft muddy conditions. Okay, we are making conditions that allows the ponding of the water, means we are compacting the soil surface. So whatever water we are putting on the basin, right, that we have created for rice, that gets stored water and it not move through infiltration to provide the better environment for transplanting the rice seedlings. While other options are like pod filling, that is stage in the plants like legumes where seed develops inside the pods. And pruning involves the trimming of plants to remove the unwanted branches and parts. And none of the above, it's not right. So correct answer is pudding. Which soil has the highest water holding capacity? So this we have already or earlier also we have discussed that sand have the largest biggest size. Afterwards, silt, and after that we have silt and clay. So what is the size of sand particle? That is 2 to 0.05 mm. Then we have 0.05 to 0.002 mm, and whatever particle less than 0.002 mm, it is known as clay particles. And we know that water holding capacity means ability to hold water. So in this, if you see here sand, for sand, whatever water will come on soil, what will happen to that? That will move quickly to the soil, right? Due to the higher availability of the porosity, means larger porous space. It means lesser specific surface area. So whatever water will come on the sandy soil, that will move quickly and percolate downwards. While silt have the combination of uh, particles, smaller particles, and the size we have shown that is 0.05 to 0.002 mm. So it have a relatively higher specific surface area compared to sand, and also the number of pore space in this silty soil is higher. Means have it can store more water, and for clay we have the highest specific surface area, and also the porosity is higher. Okay, even the small size of pores are available in clay soil, but the overall porosity of this soil is higher, and the soil, the water present above the clay soil, it moves down into the layer very slowly. Okay, due to the higher specific surface area. It means it has the highest water holding capacity also. Okay, and what is loamy soil? So loamy soil is the combination of sand, silt, and clay. Okay, it have a good water holding capacity, but it is not the highest. Okay, it cannot store more than clay soil. But for agricultural condition, generally loamy soil is better. So correct answer is C. Clay soil has the highest water holding capacity. Then what is the major nutrient generally applied through fertilizer? So we know that major nutrients, generally plant essential nutrients are divided in two parts, that is macronutrients and micronutrients. So macronutrients nutrients, we can say it is N, P, K. N means nitrogen, potassium, phosphorus, sulfur, calcium, magnesium, all that are macronutrients, while some important micronutrients are chlorine, boron, manganese, nickel, zinc, copper, iron, etc. Okay. Now the question is, what is the major nutrient generally applied through fertilizers? Okay. Carbon is required by plant. Okay, but that we are not applying through the fertilizer. Generally, carbon from air that soil can absorb. Okay. Then nitrogen that we are applying through fertilizers like urea, ammonium sulfate, ammonium chloride. So correct answer is nitrogen. So next is hydrogen. That is also incorrect. Hydrogen, though it is required by plant, right? But that is getting through the whatever water we are applying. Okay, that is available through water. Similarly, oxygen that again take from water as well as the air present in the atmosphere. So correct answer is B. Next question, which soil particle has the highest specific surface area? So this we have shown, okay, in previous slide also, right here. If you can see here, for sand, silt and clay, so sand has the lesser surface, specific surface area, right, as compared to clay and silt. Why? Because the number of particle present per this unit square is more for clay soil, right, as compared to sand. It means it have the clay have the highest specific surface area as compared to sand and silt. So you can see here also, so specific surface is the total surface area per unit mass of or unit volume of soil. So that is higher for clay, right? So per meter square, we have more than 25 gram of unit mass of soil. And for sand, it is less than 10 meter square per gram. Okay. So correct answer is clay for this option. From the given option. Now, next question. What is the effective diameter range of mesosphere? So, mesopores generally classified based on the IUPAC. So, whenever size is less than 2 nanometer or less than 0.002 micrometer. So, where we are found this condition, these are found in the internal pores space of minerals like zeolite or ferrihydrite within the interlamella space of this particular mineral. Why it is important? So micropores in a material science is a crucial application of catalyst and gas separation. So this classification basically for the material science. Okay, overall major classification. So that is micropores, mesopores, and macropores. But for soil scientists, generally we are classifying the mesospores as a 0.03 to 0.08 mm. So correct answer is A. Which component of soil occupies the 45% volume? So this we have already discussed earlier also. 45% is occupied by soil mineral particles. So option C is correct. Next, soil is an interface between lithosphere, hydrosphere, atmosphere, and biosphere. It is true or false? Anyone? Udbhav, what's your take and why? Payal, please guys discuss so I can get sure that you are following me, you are with me. So why it is true? Soil is the interface between lithosphere, hydrosphere, atmosphere, and biosphere. This again we discussed earlier, right? Because whatever soil present here, it have a direct relation with the lithosphere. Lithosphere means all the soil materials, right, present beneath the earth surface. We are growing the plants on the soil, okay, and these plants gets interconnected with the atmosphere, right? Whatever rainfall is falling, that is from atmosphere, and the soil present here, lithosphere, will help us in moving the water from one place to another place, from our ocean, water resources. Also, whatever water is coming through rainfall or irrigation, it's also moving down through lithosphere. And this lithosphere also contain aquifers, freshwater aquifers. That is also known as the groundwater. So all these are gets interconnected, right? Whatever water present here, that's also moving towards the hydrosphere. We are using this aquifer water for agriculture. Okay. Also, For agriculture, we are using air, the suitable climatic conditions to grow the crop. So this is true. Okay. Next question, which of the following particles have sticky and malleable properties? So what sticky properties? We know that the water holding capacity of which soil is higher among this? That is clay. And why it is like that? We know that the clay have the higher specific surface area. It means we have the more number of particles, weight, that mass of soil per unit area or per unit volume of soil is higher, right? It means whatever water will come here, that will get that will form the condition like sticky, right? If you have observed in the the clay soil, okay, in particularly uh, in the alluvial region or in the floodplain, we can observe the condition like this. Okay, so clay particles are the smallest soil particle having high surface area to volume ratio. It can hold more water, resulting in a stickiness and elasticity that makes them malleable. So option C is correct. Next question, which nutrients are mostly obtained from air and water? So that we have discussed earlier also. So here answer is CHO. That is a carbon, hydrogen and oxygen that nutrients are taking from the air and water, right? So option B is correct. Next question, which of the nutrients is used by plants mainly in cationic form? So what is cation and anions? I think you know the basic difference. Whatever element is there, if that it have a positive, sorry, if it have a positive charge on that, it means it have a cation, and if they have a negative charge, that is known as anion. So and cations are usually formed by metal atoms, and anions generally formed by non-metal atoms. Okay, that is the basic difference. And cations are attracted to the cathode, cathode, and anions attracted to the anode. Cations form electrostatic interaction with anions to form ionic compounds, and anions forms electrostatic interaction with cations to form ionic compounds. So both anion cations forms the ionic compounds by electrostatic force. Now here question is the which of the nutrients is used by plants mainly in the cationic form? So phosphorus is in the form of, see here, it is in negative form, right? HbO4 minus 2. Negative, it means it have anionic charge, right? Then potassium, if you know, it have a metallic property that have a K plus, right? K plus means cationic. So it have the positive charge. So correct answer is potassium. And sulfur again is SO4 minus, right? So it have the anionic form. Next question, which is not a physical weathering process? So here various processes given like exploitation, freezing and thawing, dissolution, and D is expansion and contraction. So let's understand each process one by one. Exploitation means this is the physical weathering process where rock layers peel off with the temperature changes causing expansion and contraction. So it is basically related to the temperature exploitation, right? Then freezing and thawing is another physical weathering process which in which what is happening? Freezing and thawing, water is entering into the rock cracks, right? It freezes and expands, causing the rock to break and becomes a part of with physical weathering process. While dissolution, if you know, it is a chemical weathering process where minerals in a rock dissolve in a water and acidic solution, altering their chemical composition. And this is not the physical weathering. And expansion and contraction, it parts of the exploitation. So it is part of the physical weathering process. So correct answer is C. Weathering doesn't involve both destruction and synthesis. It is true or right? It is true or false? It is false, right? Why? Because weathering process that breaks down into smaller particles. So rocks that breaks down into smaller particles, altering their physical structure and sometimes their chemical composition. It involves two aspects, destruction and synthesis. So what is destruction? Destruction is breaking down large rocks into the smaller particles such as physical weathering or dissolving minerals, and synthesis the formation of new minerals or compounds such as clay formed during chemical weathering of silicate minerals. So this is the important process, right? Destruction and synthesis during the weathering. Means this is a false. Next question, the materials deposited from suspension or precipitated from solution are called igneous rock, magma, ANB and sedimentary rock. What is question? Material deposited from suspension or precipitated from solution are called. So correct answer is sedimentary rock. Because whatever rocks formed from magma during volcanoes, that is known as igneous rock, right? And to these igneous rocks over the time by weathering and erosion process, what is happening? This igneous rocks gets break down into the small particles, right? And that is known as sediments. And whatever sediments formed by weathering and erosion nearby this igneous rock, that gets again transported to the another location by weathering and erosion, and this material gets deposited from suspension and precipitated from the solution, right? During water erosion particularly, it forms layers of the small particles, and over the times due to the compaction and cementation, this small particles form the sedimentary rock. Okay, so correct answer is D. So here this process we have already discussed earlier also, right? Let's quickly revise. So whatever magma present beneath the earth surface, so during the volcanoes, uh, like by heat or pressure in beneath the earth surface, that gets explode the magma, and after cooling down of this magma, there is a formation of igneous rock, and during weathering and erosion process, this igneous rocks gets break down into the small sediments, and This forms sediments nearby these rocks. What is happening to that? It again gets moved to the another place, right? By the force of wind or rainfall that is generated runoff and the compaction and cementation of these small particles over the time forms a sedimentary rock like sandstone. Okay, let's take next question. Chemical weathering is more prevalent in. So that correct answer is warm and moist condition. Why? Because chemical weathering involves the breakdown of rocks through chemical reactions such as hydrolysis, oxidation, and carbonation. This process requires water, right? Because water acts as a medium for chemical reactions that we have already discussed. Even for whatever fertilizer we are applying, that also require water to get dissolution, and plant only access the mineral nutrients from in dissolved form. So dry and cool climate not suitable, right, due to the lack of moisture, while warm and moist climate ideal for chemical weathering because warm temperatures speed up the reaction and moisture facilitate the process, right? So correct answer is B. Warm and moist conditions are most suitable for chemical weathering processes. A polar region, it is a cold region, right? Extremely low temperature that slow down the chemical reactions, also biological reactions, and water is also available in the frozen form. Means it cannot get react easily. While in arid region, we have the lack of water availability, right? So in arid region, what kind of weathering is happen? That is physical weathering. That is either by rainfall or wind erosion, right? That is generally happening in arid region. A horizon of the soil consists of particularly partially decomposed organic matter. True or false? So we know that A horizon, often referred to as the topsoil, typically contains a mixture of mineral particles, organic matter, water, and air. So in this layer, we have the organic matter, which includes the plant and animal debris, at various stage of decomposition. It means it is true. How E horizon is formed? We know that it is formed by illuvation process. Okay, it means illuvation form means what is that? E horizon is also known as the zone of illuvation. Okay, illuvation means it's formed due to the removal or leaching of silicate clays, iron, aluminium, nutrients or organic compounds by water percolating through the soil. Let's understand here. Suppose organic matter, the top layer, top few centimeters, we can say 2 to 3 centimeters of the soil, we have the highest organic matter, right? And also, generally in agricultural soils, what we are doing, we are applying some nutrients, agrochemicals. So, what is happening? So, whenever we are applying irrigation or during rainfall, this applied or available nutrients, organic matter on the top surface by the process of dissolution with the water during uh, irrigation or rainfall, this is moving downwards, right? And the infiltration of the water will also carry the organic matter and agrochemicals to the downward of the towards the root zone. So whenever this materials and minerals will move below the root zone, that process is known as elevation. Okay, and that E horizon. So it is rich in mineral matter, nutrients. So right, while the elevation means accumulation of this mineral to particular zone, that is known as elevation. And transformation means involves the changes in minerals and organic components of soil due to the chemical, physical, and biological process. So E origin is formed by elevation process, and elevation is known as removal of materials from soil layers by water. Okay. Next question: which of the following is not a master soil horizon? So here we know that A, R, C, all these are the master part of master horizon, but Q is not listed in that. So correct answer is B. Next, in which season soil develops slowly? So we also understand this earlier also, right? Fundamental requirement to develop a soil is the water, right? We require the erosion of rock or weathering of rocks. So if we talk about summer, so it have a high temperature that increase the rate of chemical weathering, leading to relatively faster soil development. Okay, but here we do not have water. Autumn season, so this season acts as a transition period while weathering and organic accumulation may occur. Okay, it is not the slowest season for soil development. Rainy season, so rainfall accelerates the soil formation that we discussed through the chemical weathering or physical weathering. While dry or cold condition, process is due to the absence of water. While cold climates, we have the frozen water present in a frozen form. So it means the water cannot get react easily with the soil, and also biological and chemical activity also gets slow. So due to that, the soil develops slowly in this kind of situation. So answer D is correct for this question. Dry and cold season develop soil slowly. Next question: the study of soil as a naturally occurring phenomena is called, that is known as pedology, right? That we have discussed during our summary content also, whenever we are summarizing our week content. So correct answer is C. Okay, so I think we are running out of time. So we'll see this two question in upcoming lectures. So if anyone have any question, please feel free to ask. We have few more minutes left. Okay. Also, if you have any specific question, you can Also, write down to this given email ID. We'll try to return reply within 24 hours during week work hour. Okay. So if you do not have any question, let's close this session, today's session. Thank you so much for joining. I hope you are enjoying this course and will together learning this content about soil science and technology. Thank you so much for joining. Thank you.